Okay, first we have a handout that talks about scientific notation and arithmetic operations. For scientific notation, there's one rule, one digit to the left of the decimal point. Why are we going over the rules for adding, subtracting, and multiplying and dividing? Because even though we're going to be using a calculator on every single test and quiz, what can happen is that we make mistakes. We press the wrong button. I do it all the time. So what we need to do is we need to always in this class look at our answer and ballpark to make sure that the answer is correct. Okay. So this handout goes over the rules and it also has examples, but we're going to look at the ones that are in the notes. So first of all, the rules are when you add and subtract, if the exponents are the same, what you do is you just first, whatever the number in the front's called, I know it has a name in math, I don't remember it. So 5 plus 2 is 7, and then 10 to the third, the power stays the same. But we want to practice doing this on our calculator, because this is the calculator that we're going to use on our test and quiz. So we're going to actually work this together. So we're going to say 5, and then we don't press 10 to the something, because then our answer is going to be off. In order to have an exponent, if you look at the calculator, see where it says EE? That means exponent. So now when you press that, you see how the little numbers are smaller? Okay? So that tells me it's now 5 times 10 to some power. So the first one is 3. So that's 5 times 10 to the third. Then I'm going to press plus, and then 2EE3. And then I'm going to press the equal sign. Now, if you notice, I have a large number, 7,000. If I want it in correct scientific notation, if you look behind the number 5 button, on this calculator it happens to be green. On some of you have a yellow one. But do you see how it says SCI behind the number 5? So that SCI means scientific. So if I want this in correct scientific notation, I just press second, and then I press that, and now see how it says 7, and then the 3 is smaller, because that's 7 times 10 to the third power. Does everyone see that? Okay. Now, what if the exponents are different? Well, if the exponents are different, if you did this by hand, you would make sure they're the same. So the bottom line with the one we just worked, which I forgot to mention, was if I was adding this on a test, I'm going to say to myself, I know that the final answer should either be 10 to the third or 10 to the fourth. Because if these numbers came out to be more than 10, it would bring it over to a larger number. So I'm going to say this should be to the third or the fourth. If this is to like the 6th or the 9th, I know I did something wrong. So that's why we still need to know the rules, because we want to ballpark our answer. If the exponents are different, if I did it by hand, I would make them the same. So this one's to the fourth and this one's to the third. So this example was I made them both to the fourth. So this one I left the same, 4 times 10 to the fourth, and then instead of this one being 5 times 10 to the third, I changed it to 0.5 because I made it a higher power. And then if I added it, 4 plus 0.5 is 4.5, and then the 10 to the fourth. Did I have to do it that way? No. What I could have done is I could have said 40 times 10 to the third plus 5 times 10 to the third, and then I would have 45 times 10 to the third, and then I would need one more step to put it in correct scientific notation, one integer, 4.5 times 10 to the fourth. Is this way wrong? No, that's correct. It's just one more step. Which way should you do it? Well, remember, you're going to be using a calculator, but it's important to know these rules. So if we did this one on the calculator, I would say 4EE4 plus 5EE3 equals, and then it says 4.5 times 10 to the 4. Now for multiplication and division, what we do is we multiply out the numbers in front. This wasn't a good example. And let's look at the division one. I don't have a good... Maybe on the homework I have one. I'll look at the handout for a good example. So with division, what happens is we actually divide the number in the front, and then we subtract the exponents. For multiplication, we add the exponent. So in this case, let's do this on our calculator. So we're going to have 7.5 EE5 divided by 3 EE2 equals, and it says 2.5 times 10 to the 3. Remember, these are the calculators that you're going to be using on every single test and quiz, so you don't want to try and figure it out on the test and the quiz, and I'm not going to be able to tell you what to do on the test or quiz. So we're going to practice today using these, and then when we review on the test, we'll also practice using these calculators. My suggestion is to go ahead and spend that $9 and buy one yourself so you can practice with it at home. So here, again, this shows you how to do it if you were going to do it in your head. And if you want to practice with some of these to make sure you get the right number, 4EE. Oh, okay, so this one has a negative exponent. So if I was to do that one, I'm going to press 4EE, and when I press 8, see how it's positive? So to make that a negative exponent, you see this little button on, you see this little button here on the bottom that says plus minus? If I hit that and you look now, you see it says -8. Okay? Then I'm going to press times 1.2 EE5 equals, so then it gives me my correct answer, 4.8 times 10 to the -3. So that's how you do a negative exponent. So again, you can practice with these. We're going to practice with some other stuff as well. Now again, with this one, you have to ballpark your answer. So when I'm looking at this, I don't care so much about this. I mean, you could do this math in your head as well. The main mistake that people make is they press one of these wrong. You know, like either, you know, they'll press multiplication instead of division or something like that. So when I'm looking at this, 5 minus 2 is 3, so my answer should be ballpark 3. You know, depending upon these numbers in the front, it could be, you know, larger or smaller, but that should be ballpark. If I had to the 7th power or the 10th power, then I say, I know I made a mistake. Let me go back and do it. So that's why it's important to understand the rules. All right. The next thing we need to know in this class in physics, we're always going to be doing using equations, but we're always going to rearrange the equation to solve for the unknown in terms of the known, which means using actual algebra. So we have to make sure that, and all of these pretty much are actual physics equations. So we're going to do some of these together, and then you're going to finish these on your own. So let's do number 11. So number 11, and again, you'll be able to write it on the sheet. And we're going to do it step by step. So number 11, this is a physics equation that says v squared, and it should actually be vf squared, is equal to, and we call this v naught, we'll call it I. Vf squared is equal to v naught squared plus 2ad. And I want to solve for a, which is the acceleration. Whenever we're doing algebra, we always want to rearrange the unknown to solve for the known. And the way that we do this is we always want whatever we're solving for to be in the numerator on one side of the equal sign all by itself. Okay? So because I'm solving for a, and it's already like on this side of the equal sign in the numerator, I'm just going to leave that alone. Because there's a plus here, if I want to get rid of this, this means I have to subtract it. So now I'm going to have vf squared minus v naught squared is equal to 2ad. That would be my next intermediate algebra step. Because I want to solve for a, what I can do is I can divide both sides by 2, and I can also divide both sides by d. So vf squared minus v naught squared over 2d is equal to a. So now I have my unknown in terms of my knowns, and then what I would do is I would substitute in my values and solve if this was an actual physics problem. Okay? And on the FRQs on the test, you have to show your intermediate algebra steps, and the same in your homework. You're just not going to plug numbers into a formula. A lot of times in college physics, the problems have no numbers. You have to rearrange the variables. Okay, let's do number 16. So number 16 is an actual equation that we use in physics, and that's the equation for the period of a pendulum. So the period of a pendulum t is equal to 2 pi times the square root of L over g. L is the length of the pendulum, and g is the acceleration due to gravity. Now, we want to solve for, we're going to call this little g. We call this lowercase g, we call it little g. So we want to solve for little g. Now, if we want to solve for this, I don't know, honestly, how you're going to put in your calculator, if you were given t and L, how you're going to put those numbers in your calculator to solve for something that's in the denominator of a fraction underneath a radical, because I would have no idea how to do that. So what we're going to do is we're going to rearrange this equation to solve for g, and we're going to do it step by step. Okay, so the first thing we want to do is, the 2 pi is not under the radical. So to get rid of the 2 pi, we're going to divide both sides by 2 pi. So t divided by 2 pi is equal to the square root of L over g. Now what we want to do next is we want to get rid of the radical. So if I square this side, because remember, a square root means to the 1/2 power. So if I square it, but I have to square both sides. So I'm going to have t over 2 pi squared is equal to this. So when I actually square it, now this is the biggest mistake that people make over and over and over again. When they square the t, they forget to square everything in the denominator. So this is going to be t squared over 4 pi squared. You have to square the 2 and the pi, and that's equal to L over g. Whenever you have a fraction, what's your go-to? Is there a math rule called flip it? No. Don't ever, 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 ever just say, I'm going to flip it, because there's no such thing. Whenever you have a fraction and you want to get rid of the fraction, your go-to is called cross multiplication. So cross multiplication means this times this is equal to this times that. So that's what we're going to do. So we're going to say t squared g is equal to L 4 pi squared. Now I see that g is in the numerator, so I'm not touching that g. It's already in the numerator. I want to solve for g. Is that 16? Yeah. So I'm going to leave that g where it is. So to leave g in the numerator by itself, all I have to do is divide by t squared. So g is equal to L 4 pi squared over t squared. And that's it. That's my unknown in terms of the known. Okay, now we'll look at number 17. Now 17, in actuality, there's a physics equation. It's not written on here. It says 1 over f is equal to 1 over di plus 1 over do. That's the physics equation for 1 over the focal length is equal to 1 over the distance of the image, but 1 over plus 1 over the distance of the object. But sometimes those variables might scare you. So on the worksheet, when I typed it up, I just wrote 1 over x plus 1 over y is equal to 1 over z, and I said solve for y. Is this the same math that we have to do? It is, but I just did, this to make it simple. So we're going to solve for y. So remember, when we want to solve for y, the first thing is it needs to be by itself, and it needs to be in the numerator. Can I just flip all these? No, no, no. There's no such thing in math as flipping. Okay. So first what I'm going to do is I'm going to isolate the y. So I'm going to take this 1 over x and I'm going to move it to the other side. So I'm going to have 1 over y is equal to 1 over z minus 1 over x. Now, the issue here is I want to simplify this, but there's a negative sign here, and they have a different denominator. So what I need to do is, in order to perform this subtraction and simplify it, I have to find a common denominator. The only common denominator here is going to be what? Z times x. Okay? So in order to get zx here, I'll have to multiply top and bottom by x. In order to get zx here, I'll have to multiply top and bottom by z. So I'm going to have 1 over y is equal to x times zx minus z over zx. Now, because the denominators are the same, I can perform the subtraction. So I have 1 over y is equal to x minus z over zx. Now, I have a fraction and I want to simplify. Do I flip? No. What I do is I cross multiply. Cross multiplication is your best friend whenever you want to get rid of a fraction. So I have zx is equal to x minus z times y. So now I want to solve for y, so I'll divide by this. So z over x divided by x minus z is equal to y. This is my unknown in terms of my known, and this is actually just Algebra 1. And that's it.